That's somewhat what they're trying to do now with pumps turning on and off. You can look at other declines in the ecosystem. You can do creative things like build salinity gates that let you pull out more water and you manually control for that. You can mandate different uses of pesticides so that you don't have as many toxins coming into the system. There's lots of creative solutions, but I wanted to bring this up because this is somewhat manageable, right? I picked one part of the State Water Project in one system, and yet we still can't decide how to manage it. So if you scale this up to a global scale, the idea is somehow you have to make all these stakeholders feel invested and come up with a solution that's both sustainable from an economic, ecological, and cultural standpoint. I don't have the answer. There is no big conclusion answer slide. But the idea is that when water is one of those issues that touches every aspect of our lives, and thus it becomes a huge management issue. Any questions about the Delta example? You'll see it in the news a lot. This is a year when they're probably going to have to shut off the pumps. And we've had a big drought. We've been in a drought for numerous years. So you're going to see it again. The last time it was huge was 2007. So, there's articles out there about that this year is going to be another 2007 and things like that. So, the governor, Arnold Schwarzenegger, is no longer in power, so the peripheral canal has been taken off the table, and Jerry Brown hasn't indicated how he'll deal with this challenge. He tends to be slightly more environmentally friendly than Schwarzenegger was, but he's also very concerned about business, so I have to keep our eyes out. So why don't we do your break now, and then I have sort of water quality and solutions when we come back.
Yeah.
So I'm going to start back up, and we're going to go through a couple. These are a little more listy. What I want you guys to have, what I think is really important when you're working on sustainability, is that this is a multi- and interdisciplinary field of sustainability. So that means you don't have to be an expert in everything that you are going to deal with, but you do have to recognize the importance of it and know how to talk the talk. Know what the vocab means, know how to apply it. So from the lecture today, you're not going to know how to go out and do water quality testing, but you'll at least know when you hear someone talk about water quality standards, what they're talking about, why it's important, things like that. So water quality is divided into three main parameters that people are looking at. Chemical indicators. These include pH. This somewhat includes oxygen as well. We talk about biological oxygen demand, chemical oxygen demand, and just general dissolved oxygen. It also looks at metals, some element of hardness, how many pollutants that are in there. So those can be pesticides or fertilizers like nitrate and phosphorus, or orthophosphates, which are often herbicides, or surfactants. Surfactants are what are used in herbicides to hold it onto the plant. For example, there was just in the news yesterday when I was driving home, how many people know what chemical is put on strawberries in Northern California? It's called methyl bromide. So methyl bromide is the only one that they found effective for preventing fungus and herbivorous activity on strawberries. There's actually an EPA ban on using methyl bromide because it's toxic to humans. However, since putting the ban in place in the EPA, the methyl bromide use in the United States has doubled. How's that possible? No, people are still using it on strawberries all over the country because there is no alternative. So we apply for exceptions in California to use methyl bromide on strawberries because there's no alternative to methyl bromide.
So strawberries are poisonous?
Wash your strawberries well.
We use a lot of bromide.
Obviously people aren't dying from eating strawberries, or that would be a real health issue. But the idea is that these sort of pollutants and surfactants that exist are still making it into our system through various agricultural ways. I used up the methyl bromide example because it was in the news again yesterday. California is applying for more exceptions to use methyl bromide on strawberries.
We're also using bromide for a lot of the forest fires.
Yes.
It's the best extinguisher, but they are really big sink of the ozone,
Okay.
ozone hole. So that's very important because.
I do have fire.
But we don't have any substitute for it.
Right, and they used to have methyl iodine, but that's actually even worse, so they pulled that. Physical indicators, these are a lot of, literally what the water feels, tastes like, etc. So water temperature, conductivity, which is a measure of how salty it is, turbidity, which we'll talk about, suspended solids, and then things that we care about when the water arrives at your tap: odor, color, taste. Then there are biological indicators. These are what sort of bacteria, particularly E. coli, that are in the water, and then what invertebrates can live there. So if you look, these are some of the examples that I have for chemical properties of water: pH, sediment, nutrients, dissolved oxygen, temperature, metals, and minerals. Those are the big things that people are looking. How do these translate to stream health? Well, pH, you can have water. Typically, water, both in the ocean and in fresh water, doesn't fluctuate along a very wide pH. It's usually around 7, remains around neutral. However, if you do have slight perturbations to this, it affects the type of organisms that can live in the water, and it can affect, their ability to lay down shells or other features. What do people measure when they're measuring this? I mean, usually we're looking at the concentration of these chemical elements within the water. So you're looking at milligrams or micrograms of chemical per liter of water. You also see ppm, parts per million. You see milligrams per kilogram if it's solid to material. And you can take a single point in time or a mean over time. Both of those are sort of the legal definitions by which pollutants are measured. And then you see these things called pollution loadings. So this gives you an idea of a function of total discharge. So however much it's scaled by how much that watershed or stream has in terms of water flow. So it's not just how much is there as an absolute amount, but how much is coming in almost per capita, almost per discharged. So people look at this over the duration of an event, like a storm. And you'll see numbers like total daily maximum load, TDMLs. These look at, these are the parameters that the State Water Board regulates on. Where is water pollution coming from? There's all sorts of natural sources. When I say animal waste is a natural source, I'm really looking at this from the perspective of naturally occurring animals not having feeding operations around the stream or something. There's a lot of particulate that comes from forest fires. Having a flood brings a lot of sediment into there, and rocks decompose through weathering. This is a natural contribution of metals to stream beds. But there's a lot of anthropogenic sources that way exceed the amounts that come in through these natural sources. Irrigation, pesticides, industry, automobiles, landfills, all of those are releasing water pollution. It usually happens in two different sort of methods. One is an aerial deposition, where you have particulates in the air like dust, chemicals, and they settle out on surfaces by rain or by fog. There's been some recent studies, one just came out in Science within the past couple of months, looking at how far these aerial particles can travel. They found bacterial particles that they could trace from Asia genetically that are arriving here in the United States via dust particles in the air. You also see, Asian dust cloud, they call it. You can see it on maps coming from, deserts over into the United States. We also have land-based discharges, so these can either be point source or non-point source, which I'm sure you guys have heard the terms before. Point source is a pipe or channel that directly is discharging, so these tend to be where you see industry or water reclamation coming in. Non-point source pollution is very difficult to track. These are diffuse sources that are coming in from runoff. Typically, this is stormwater. You see it every day when people over-irrigate their lawns, and you just see runoff going down into the streets. And, this is very difficult to assign blame to. Here you can go to the pipe, see whose waste is in that pipe, assign a polluter to that problem. Non-point source is much more difficult to manage, and part of that is because living in an urban area, we have a lot of impermeable cover. So that impermeable cover, like pavement, sidewalks, roads, all of that is